morning students. Welcome to 11th standard chemistry video class. We are discussing lesson 2 quantum mechanical model of atom. In this video we will continue with the energies of orbitals. Based on the n plus L rule, the increasing order of energies of orbitals is as follows: 1s orbital less than 2s orbital less than 2p orbital less than 3s orbital less than 3p orbital less than 4s orbital less than 3d orbital less than 4p orbital less than 5s orbital less than 4d orbital less than 5p orbital less than 6s orbital less than 4f orbital less than 5d orbital less than 6p orbital less than 7s orbital less than 5f orbital less than 6d orbital. Again I repeat, based on the n plus L rule, the increasing order of energies of orbitals are given here. As we know, there are three different orientations in space that are possible for a p orbital. All the three p orbitals, namely px, py and pz, have same energies and are called degenerate orbitals. However, in the presence of magnetic or electric field, the degeneracy is lost. Hence, p orbitals with three different orientations are three different orbitals, namely px, py and pz. All these orbitals have same energies and are called degenerate orbitals. When these orbitals are placed in the magnetic field or electric field, the degeneracy is lost. It is explained in this paragraph. In a multi-electron atom, in addition to the electrostatic attractive force between the electron and the nucleus, there exists a repulsive force among the electrons. These two forces are operating in the opposite direction. This results in the decrease in the nuclear force of attraction on electron. In a multi-electron atom, there are two forces acting. One it is called attractive force and the next one is called repulsive force. Here the attractive force takes place between electron and nucleus, where the repulsive force takes place between the electrons. Hence the attractive forces and the repulsive forces are operating in the opposite direction. This results in the decrease in the nuclear force of attraction on electron. The net charge experienced by the electron is called effective nuclear charge. Hence, we are having the definition for effective nuclear charge. It is an important question. They will ask, what is effective nuclear charge? You have to give the answer. The effective nuclear charge depends on the shape of the orbitals and it decreases with increase in azimuthal quantum number L. The effective nuclear charge depends on the shape of the orbitals and the effective nuclear charge value decreases with increase in the value of azimuthal quantum number L. The order of the effective nuclear charge felt by an electron in an orbital within the given shell is S greater than P greater than D greater than F. Here the effective nuclear charge felt by an electron in an orbital within a given shell is given by S orbital greater than P orbital greater than D orbital greater than F orbital. Greater the effective nuclear charge, greater is the stability of the orbital. Here, within a given energy level, the energy of the orbitals are in the following order: S less than P less than D less than F. Again I repeat, greater the effective nuclear charge, greater the stability of the orbital. That is, the energy of the orbitals in the order of S orbital less than P orbital less than D orbital less than F orbital. It is explained in the paragraph. This picture explains the energy levels of atomic orbitals. It is in the increasing order of energy. 1s orbital with the lowest energy, and it is arranged in the increasing order as 2s orbital, 2p orbital, 3s orbital, 3p orbital, 4s orbital, 3d orbital, 4p orbital, 5s orbital, 4d orbital, 5p orbital, 6s orbital, 4f orbital, 5d orbital, 6p orbital, 7s orbital, 5f orbital, 6d orbital, and 7p orbital. Again, I repeat, this picture explains the energy levels of atomic orbitals. It is in the increasing order of energy. The energies of same orbital decrease with an increase in the atomic number. For example, the energy of the 2s orbital of hydrogen atom is greater than that of 2s orbital of lithium, and that of lithium is greater than that of sodium, and so on. That is, energy of 2s orbital of hydrogen is greater than energy of 2s orbital of lithium, which is greater than energy of 2s orbital of sodium, and is greater than energy of 2s orbital of potassium. If the electron is present in the same orbital, for example, if the electron is present in 2s orbital, their energies of same 2s orbital decrease with increase in the atomic number. Here we are taking hydrogen, lithium, sodium, and potassium. The atomic number increases from hydrogen to potassium, and the energy decreases from hydrogen to potassium. It is given by energy of 2s orbital of hydrogen is greater than energy of 2s orbital of lithium, greater than energy of 2s orbital of sodium, which is greater than energy of 2s orbital of potassium. It is explained in this paragraph. Next topic, filling of orbitals. In an atom, the electrons are filled in various orbitals according to Auber principle, Pauli exclusion principle, and Hund's rule. These rules are described below. Here, in an atom, the electrons are filled in various orbitals based on Auber principle, Pauli exclusion principle, and Hund's rule. Let me discuss one by one. First, we will start with Auber principle. Auber principle. The word Auber in German means building up. In the ground state of the atoms, the orbitals are filled in the order of their increasing energies. That is, the electrons first occupy the lowest energy orbital available to them. Auber principle states that In the ground state of the atoms, the orbitals are filled in the order of their increasing energies, which means the electrons first occupy the lowest energy orbital available to them. It is an important question. If they ask state above principle, you have to write this paragraph. Once the lower energy orbitals are completely filled, then the electrons enter the next higher energy orbitals. The order of filling of various orbitals as per the above principle is as follows, which is in accordance with N plus L rule. Here, after filling the electrons in the lower energy orbitals, the electrons will enter into next higher energy orbitals. It is based on above principle and it is accordance with N plus L rule. It is explained here. Here, above principle explains that in the ground state of the atoms, the orbitals are filled in their increasing energies. First, the electron occupies 1s orbital, then the electrons are filled in their increasing energies, which is shown in the picture. Let me stop up to this topic. The remaining topics that we will discuss in our next video class. Thank you.